Algebra 2, lesson 8.7, we're going to come back to log properties. We saw last time that we could condense logarithms, that if you had two logs that were being added together, you could see log written twice. You could write it once and then multiply their inside parts together. If you had two logs that were being subtracted, you could condense those and write them as the log of a over b. And finally, if you had a log of a to the n, if you just had that power, you could bring the power down in front. Guess what we want to see is that you can always go ahead and go in the opposite direction as well. You could start on these left sides here of log of a times b, log of a over b, and expand in the same way. Likewise, if you had an n, you could bump it up and have it written in that regard. So we're going to be using either of the yellow or green ideas here. It depends on what we're going to have. We are going to need to expand for number one. And when we're expanding, we're working here in green. You can see that we've got the log of x squared times y. There's implied multiplication. I hope you're going to see that this is really the same thing as the log of a times b then would equal the log of a plus the log of b. So we're going to write this then as the log of x squared plus the log of y. But each logarithm should involve only one variable and should not have powers. So we're going to look at this power here and bring it down. That's ultimately over here. Really, these two things are typically going to be switched. Anytime you have a power out in front, you can drop it down as a coefficient. So this becomes 2 log x plus log y. And then we're done. When we're getting to example 2, we see that we have a fraction, and that's really what we're going to have right here. This is going to be the log of a over b would equal the log of a minus the log of b. And, at this point, we can see that what we've written here, this is going to become the log of y to the third as we expand this minus the log of z. But then just like we did before, if you have an exponent, you have a power up here, you can drop it down and bring it down in front because we should not have any exponents inside for these problems. So we'll take that 3, write it out in front. And we have expanded. We took one log and we turned it into 2. Now, when we're getting to these last problems, we're actually going to have to condense and go to a single logarithm. And I guess what I want to tell you from the very get-go is that you should always do what's inside of parentheses first. Should always do what's inside of parentheses first. So, as we're looking here, we're going to be able to see that this subtraction is that second property that we have there. So, I'm even going to write that up above, like if we had, say, the log of a minus the log of b, that's going to become the log of a over b. However, here's this issue of the power again. You can't just jump to that. You have to take any coefficients, any numbers out in front, and raise this up. So in other words, notice what we're doing. We're not going to distribute that 2 out in front here. That's so tempting to do in a problem like this. What we're going to do instead is just focus in wherever we've got some parentheses. If you've got an x coefficient out in front, we're going to raise it up as an exponent. So this is going to be minus the log base a of z squared. So that's going to have to be our first thing here. By the way, with this 3, we'll just recopy this just for a moment. And now we can go ahead and say, hey, this thing right here looks just like that principle that we saw earlier. So I'm going to recopy this. I've got my 2 out in front, but I'm going to write this as x over z squared. Remember, when we've got this subtraction, we can condense and make that into one separate log. And by the way, right now, as we're looking at that 3 log base a of y, we're going to take these numbers out in front and raise them up. This is log base a. Raise those up as powers. So I'm going to do that over here too. This 3 comes up high. And then what? Well, powers to powers we multiply. I hope you remember doing that way earlier in the year. This becomes x squared all over z to the 4th. And then finally, whenever you add 2 logs, you might remember this is where we're going to go ahead and condense but multiply their insides. So what does it become? It's x squared y to the 3rd all over z to the 4th, because really this is y to the 3rd all over 1. And that's going to be your final answer. Okay, as we take a look here at this next problem, you can see write the expression as a single logarithm. Tell you what, anytime you have a number out in front, raise those numbers up as powers. This will become log base 6 of z to the 1/5 plus log base 6 of w to the 4th. You could say minus log base 6 of just a y. And it's at this point where we can actually realize we've got 2 different properties. You can see that the first two terms here that we've got would be the addition. So remember, when you're adding 2 logs together, you condense them into one, but you're going to multiply their inside parts together. Finally, as you look right here, you're going to see this time you have 2 logarithms where you're subtracting them. And guys, when you're subtracting 2 logs, well, we can see as we're going back up to the top here, as you're subtracting, and we're looking right over here, that condenses into 1 log, but we divide their insides. So as we're wrapping up, this becomes log base 6. The numerator is z to the 1/5 times w to the 4th all over a y. And we are done.